Yeah, okay. Hi guys, my name is Fikri and we are going to talk about red black tree and we're mainly focusing in insertion. Okay, let's get to the first theory of red black tree. So, what is the characteristic of red black trees? Red black trees, every nodes are colored either red or black. During insertion and deletion, rules are followed that make sure the tree is balanced. Okay, so there are some rules in red black trees and we are going to learn about it as we go along this video. Okay, so maybe you're asking, really color? Why? So, and then you must be asking, how do we choose which color is it red or black in every node? Okay, red black rules number one. Every node is either red or black. Number two, the root of the tree must be black. So now you know when we should use black or when we should use red. Number three, if a node is red, its children must be black. The converse is not true. Black nodes can have black or red children. Red black rule number four, every path from the root to a leaf or null child must have the same number of black nodes. So these are the four rules. All nodes are either red or black. The root must be black. A red node can only have black children. All paths to leaf or null have the same number of black children. How do we uphold these rules? There are only two things we can do. The first one is color flip, and the second one is rotation. Okay, next we are going to learn. In the video, we are going to learn about color flip and how to rotate the trees. Now, inserting a new node. When we insert a new node, it's always red by default, unless it's the root. Why is this a good idea? Remember the rules. 1. All nodes are either red or black. 2. The root must be black. 3. A red node can only have black children. And the fourth one is all paths leaf to leaf or null have the same number of black children. For example, let's insert 13 here. It's root, so it must be black. And then we insert add 8. It will automatically become a red one. And then we insert 17. It is greater than 13, then we have to put it on the right. And then now suppose we insert 15 in the 17 nodes. What rule is broken? Well, like we said before, uh, red node can't have the same can have a child that is red too. So we have to change 17 to black. And that's the thing how to use color flip in this red black tree. But this is just for an example, okay? It's not true. But color flips can fix everything, okay? For example, what if we insert the 16 into this tree? We already said it's initially red. What rules get violated, okay? Let's look why will a color flip not fix it. So we initially have this situation, right? Okay. Clearly, this violates rule number 3. We have a red node, we have a red child, and that is a big no-no in this red node tree. Okay. So how to fix it? We need rotations. To fix this situation, we have to color flip to get rid of rule 3 violation, but we also have to rotate to fix the other problems. So we need both color flips and rotation. How do we do it? Let's reduce it into the general case. We initially insert 16 as a red. This example, x is 16, p is 15, the parent of x is 16, G is 17, the grandparent of X is 16, parent of P 15. So what is color flips? In insertion is to find the point of insertion, you have to start at the root and go down the tree. If you encounter a black note with two red children, flip both children color to black. Flip the black note to red and let it to root, then keep it black. At the point of insertion, remember the new note is initially red. If the new note's parent is black, just put the new note there. If the new note's parent is red, we must rotate. So, you already said them. Let's go back to the before this video, okay? If the new note's parent is red, we must rotate, okay? So, you must be asking, then how do we rotate it, right? And when must we rotate? So we've gone down the tree, flipped the color as necessary, and gotten to the point of insertion for our new node X. X is red, call its parent P. We don't have to do anything if P is black. If P is red, two possibilities, both require rotation. X is an outside grandchild of G. X is an inside grandchild of G. If X is an inside grandchild, flip the color of G. Flip the color of X. Rotate with P at the top in the direction that raises X. Rotate with G at the top in the direction that raises X. This is a perfect example. 16 is an inside grandchild of 17. X is 16, P is 15, G is 17. Step 1. Color flips. Flip the color of X, 16. Flip the color of G, 17. Now step 2. Rotate with P as the top. Rotate with P, 15 as the top in the direction that raises X, 16. In this case, it's to the left. And then step 3. Rotate with G as the top. Now we're good. Rotate with G, right, at the top in the direction that raises X. In this case, it's to the right. Rotation required. If X is an outside grandchild, it's easier. Flip the color of G, flip the color of P, rotate with G at the top in the direction that raises X. So, about insertion, I'll give you the summary. Start at the root and find the point of insertion. Go right or left just like an ordinary binary search tree. If it's greater number than the root, then go right. If it's lesser, then just go left. But as you descend, if you find a black note with two red children, flip color. If you then have a red parent with red child, rotate using rules below. At the point of insertion, you'll insert some node X as the child of P and grandchild of G. If P is black, done. If P is red, then. If X is an outside grandchild, flip the color of G and P and rotate with G as the top in the direction that raises X. If X is an inside grandchild, flip the colors of G and X and rotate with P as the top in the direction that raises X. Rotate with G as the top in the direction that raises X. So that's all about red black tree, basically in insertion. I'm sorry if my English is not really good and my explanation is a bit not on your expectation. So good luck with your red black tree. Goodbye.